Alright guys, welcome to this page of the notes, and I know it looks scary, but trust me, the information is organized about as neatly as you can organize it. Please notice the difference between the two tables. They are both for ellipses, and these are photocopied right onto that formula sheet that I've given you if you're taking this class with me. So the difference then is this is an ellipse centered at the origin. Please notice that there is no h and k. That's because there's 0. H is 0 and k is 0, and they just drop out. This is horizontal, oriented horizontally, meaning the major axis, A, is along the x, or vertical, meaning the major axis is along the y. That's why the y is now above the A. This one is if it's centered at HK, which is why there are now H's and K's in there. But again, the difference being whether it's oriented horizontally is the x over the a squared, or vertically is the y over the a squared. So the information is put together pretty nicely here in these two tables. I know it's a lot, but that's why I don't make you memorize it. Once you know the value of a, h, and k, you just come to the formula sheet and it is plug and chug. Don't fat finger something on your calculator. These should be pretty easy. So let's try an example problem together. Show you how these work. All right, what I've got for you guys right here is this. I have given you some information about an ellipse, and I want you to write the equation. Here's what I would do. I will always start these ones when given some information by plotting that information. Just throw it up on a coordinate plane, see if you can get an idea of what this ellipse looks like, and then go ahead and worry about writing your equation. So here's what I've got. Vertices. Well, I know vertices, right? Based on the diagram we just saw, graph the vertices in red, vertices are always on the end of the major axis. Co-vertices are on the end of the minor. So these will be the ends of my major axis. Let's see where they're at. X is 0, y is 9. That's that point right up there. X is 0, y is minus 9. That's that point right down there. So what I have is a vertex there and a vertex right there. I then give you the foci. Now remember, foci are always on the major axis, but they're inside the ellipse, which means they'll be, right, they should be inside of the vertices somewhere. If I wind up with a foci on the outside of the vertex, you done goofed. You made a mistake, or it's not an ellipse. So anyway, let's see what happens here. I have, okay, perfect, 0, 7, which puts me right there, and 0, negative 7 puts me right there. So there is a foci, there's my other foci, and so here's what I've got. I've got a major axis that runs right there. That is the major axis of my ellipse. So here's what I now know just by graphing my foci and the vertices. I now know that I have an ellipse that is oriented vertically, right? Vertical orientation. And is it centered at 0 or is it centered at HK? Well, please notice, right? The distance from here to here, distance from here to here, right? That's 9 up, that's 9 down, so it's 18 units on the graph. You can just count them out. 9 to negative 9 is 18. And what's half of 18? Well, half of 18 is 9, which means my center is at the origin. So this is my center right there. And so what I've got is an ellipse centered at the origin, and it is aligned vertically, which means you need y squared over a squared plus x squared over b squared is equal to 1, right? That's the one I need. It comes right off the formula sheet. Once you know you're centered at the origin and you have a vertical orientation, just copy it right off the formula sheet. Now, in order to solve this problem, I need to know, or solve this problem, I apologize. In order to write this equation, I need the value of A and I need the value of B. So let's see what I've been given. Well, what they've given me is they've given me a vertex. And right off the formula sheet, you're told the vertex, right, when oriented vertically is at 0, A. So what that tells me is that A, since my vertex is 0, 9, and its vertex is at 0A, 0, 9, so it looks like A is 9. Should be pretty easy to tell. All right. Also, they give me a focus. And right off the formula sheet, They tell you for an ellipse oriented vertically, the focus centered at the origin, oriented vertically, the focus is at 0, C. Well, if my focus is at 0, 7, that means that the value of C has to be 7. So C is equal to 7. All right, so here's where I'm at. I now know, right, that I have A is equal to 9, C is equal to 7, but I need A and B. But I've already used all the information that they've given me. Like, they don't give me anything else. So how am I supposed to find B? Oh yeah, that's right. We have a Pythagorean theorem representing the relationship of the triangle inside of the ellipse. Okay, so I go to my formula sheet, I look for the Pythagorean theorem for ellipses, and it says that C is equal to A squared minus B squared, and you take the square root of that. All right, so that's right off the formula sheet, and now it's just plug and chug. Don't fat finger something on your calculator. C is 7, A is 9, which will square, minus B squared. That's what I'm solving for. Let's see. In order to solve for this, I will need to get rid of the square root, which means square both sides. So I'll have 49 is equal, 9 squared is 81. Okay. Let's see. If I subtract 81 to the other side, you wind up with minus 32, because 49 minus 81 will be negative 32, but let me come up here. Since they're both negatives, take the negative of both sides or multiply both sides by -1, whichever. B squared is equal to 32. And actually, I can go ahead, right, and stop right there. Please notice that in my formula, I want B squared. And that's exactly what I just found. B squared is 32. So let's go ahead and write our equation for this guy. Remember, it is y squared over a squared plus x squared over b squared is equal to 1. And here we go. What is a? Well, we already talked about it. A was 9. A was 9, so 9 squared is 81. Plus x squared over, we already did it, b squared is 32. Remember, this value, the major axis, has to be bigger than the minor axis, and it is. 81 is bigger than 32, so I feel really good about that. That is the equation for the ellipse described to you here in this problem, where the vertices are 0, 9 and 0, minus 9. The foci are 0, 7 and 0, minus 7. Again, you could go ahead and draw the rest of that ellipse in there, but I didn't actually ask you to. I only asked you for the equation, which is exactly what you gave me. Hey, we'll try a couple more of these together. Head on over to the next page of the notes. I'll meet you guys there.